Hello, beautiful viewers. You're welcome once again to another fascinating maths video. In this video, we shall be considering solving problems from geometry. As usual, I shall not be considering a detailed discussion on concepts, as it will be too lengthy. And also, I would like to inform you that I also render an online mathematics tutoring service. So if you're interested in this service, be very free to get across to me via the email I provided. Or you can click the Telegram link and it will take you to my Telegram, whereby we can have a discussion regarding how the online class will be. The online class is a very interesting class in the sense that you have the privilege and all the liberty to talk to me in real life time. And if you're not clear about a certain concept, during the course of explanation, you can ask your question and I will do my possible best to get across to you in such a way that you'll be so clear and understanding. All right? So be very free to get across to me. I've been teaching mathematics for over a decade. I've taught various levels of students. I've taught the primary section. I've taught the secondary, high school students, university students, even master students. I've been involved in it for a very long time. I've been into mathematics. So I'm well experienced. And when it comes to competency, I'm very competent in it. All right. So be very free to get across to me and you shall rejoice that you have me as your online math tutor. So let's go over to the solution of this problem. We are given a very interesting geometrical problem here. It says below ABCD is a square whose size is of length x centimeters. If the area of triangle AFE is 80 centimeters squared and the length of side DE equals the length of side EC, and also angle AEF is 90 degrees, we are required to find the value of x plus y squared, given that x plus y equals to 4. Right, so we are to find the value of x plus y squared, given that x plus y is equals to 4. Now, to solve this problem, we strive to get the value of x first. If we can get the value of x, we can immediately get the value of y by the given condition, x plus y equals to 4. All right? Then thereafter, we can now find the value of the quantity, which is x plus y squared. So the first thing, we strive to get the value of x. All right? Now, this is a figure that is being referred to. This is a figure. Now, as usual, when we are given a geometrical figure, it is very important and useful to draw the diagram again. That is to do a redraw of the diagram. And in that redraw, you are to put in suitable construction that will enable you to find the value of an unknown quantity. All right? So because of that, I said let the situation be as illustrated in the following. Now, what follows is this diagram. Look at the way I drew it again. It's the same diagram you are seeing over here, but I redrew it in such a way that I have to put in profitable constructions. And the construction here is to connect A to C. That is the only construction. That is, I connect A to C. All right. Now, the line AC is called the diagonal of the square. All right. Now, we can solve. Let's think of finding the value of S, as I said earlier on. Now, how do we get the value of S? In what way? Now, to get the value of S, let us consider triangle ADE. All right. So we'll write considering triangle ADE. All right. So from triangle AED, you see that triangle AED is a right triangle. Why is it a right triangle? Because this angle here is 90 degrees, because the shape that is talked about is a square. All right. So on considering triangle ADE, we have from Pythagoras that the square of this side AE squared is equal to AD squared plus DE squared. This is Pythagoras, all right? So that is it. Now, we don't know the length of the side AE, so we can write AE squared equals to AD. Now, if you observe carefully, AD is equals to x, so we have it as x squared plus DE is equals to x over 2. Don't forget, from the statement of the problem, we are told that DE is equals to EC. Let's go back to the problem to locate these facts. Yeah, look at it over here. Can you see this? See this. This is statement of equality over here. So because of that reason, since this shape is a square and the length of each side is x, it follows that DE is equal to half of x, and also EC will be half of x, because we are given from the statement of the problem that the length of DE is equal to the length of EC. All right, so we have this already. From here we can get the length AE. This implies that my AE is equal to the square root of x squared plus x over 2 all squared. All right, from whence we have the result as s squared plus s squared over 4. Now on factoring, we have it as x squared brackets 1 plus 1 over 4, and this will give us x square root of 1 plus 1 over 4. Simplifying the radicand, we have it as x root 5 over 4, and this will break down to x root 5 over 2. That means that this length you are seeing over here is x root 5 over 2. All right, so we've gotten that length already. So we want to get more length. Now let's consider triangle ACB. All right, consider triangle ACB. Now our page is exhausted, so I will take more page to continue the work. All right, now we're considering triangle ACB. Considering triangle ACB. All right, now this is it over here. Hope you can see triangle ACB. Let me illustrate it. I mean this triangle. Can you see that? This triangle over here, that is triangle ABC. So we're considering that triangle. Now, since the length AC is a diagonal of the square, we have that this is a right angle triangle also. That is, yes, at 90 degrees. And we can once again apply Pythagoras theorem. It follows then that AC squared should be equal to AB squared plus BC squared. AB squared plus BC squared, all right? Now, the square is of length x, so that means this is equal to x squared plus s squared. Can you see that? Which will give me 2x squared. On taking the square root, we have that AC is the square root of 2x squared, which will give me x root 2. All right? We'll have this as a result. Then I can come here and label here as x root 2. Can you see what I'm doing? So we're almost there at the results. Now look at the triangle AEC. Can you see that? AEC. Observe it carefully. Or let me illustrate it so you can locate it. I mean, or you can, this thing cannot describe it appropriately. Is all right? But I'm talking about triangle AEC. All right? Triangle AEC. So consider triangle AEC. Then if we consider a triangle, we have a very interesting shape. I can even bring the figure out. Let's look at it here. Considering triangle AEC, all right? So in this case, we have this shape as follows. Let me bring my meter rule. We have something of this nature. Something like this. Then I have to make it straight. Then again, we have something of this nature. All right. Which again, that is a diagonal AC. Think it's straight now, yeah. So we have something of this also. And it's labeled as follows. Let's go to the diagram once again. I see the labeling. In the diagram, we have it as AEC. So that means yes A, yes E, and yes C. Now AE from the diagram, AE from the diagram is S root 5 over 2. We've already found that already. So I can put here as S root 5 over 2. All right. The EC from the diagram, we have it as X over 2. Then we can come here and write X over 2. And AC, we've just found AC to be X root 2. Yes, X root 2. All right. Then we should observe something more again. Observe that the angle AEC is 90 plus beta. Do you see that? Because that box there is a right angle. So the angle AEC is 90 plus beta. So I can come here and write this entire angle as 90 plus beta. So from here, we are good to go. So what we do, we shall apply the cosine rule. Now, on apply the cosine rule, don't forget I said we shall assume familiarity with concepts. So there's a rule of solving triangle. We have various rules of solving triangle, one of which is a cosine rule, which we want to apply now. So I'm assuming familiarity with such concepts. In this case, we are having that. Now, okay, let me write it first. On using the cosine rule, we have x root 2 all squared equal to x root 5 over 2 all squared plus x over 2 all squared minus x root 5 over 2, sorry, we put 2 here, 2x root 5 over 2 multiplied x over 2, then the cosine of the angle in between the sides, which is this. So this is the cosine rule, right? Then when we work this further, we shall have x squared, 2x squared, excuse me. On the left hand side, we have 2x squared, and that is equals to on this side, expanding this further, we have, excuse me, 5x squared over 4, all right? Then plus we have x squared over 4. All right. Then minus these two, we cancel out these two. So we're left with x squared root 5 over 2. Now, this cosine of 90 plus alpha can be expanded by using the sum formula in trigonometry, and it's in double compound angle. So in this case, we have cos 90 cos beta minus sine 90 sine beta. Can you see that? All right. So we have this as a result. Then we can divide through by s squared. So when we divide through by s squared, we are left with 2 equals to 5 over 4 plus 1 over 4. And that will give us 6 over 4. All right. Then we are left with root 5 over 2. Now this here will give us 0 because cos 90 is 0. So we're left with sine 90, and that will be reduced to sine beta because sine 90 is 1. All right. So minus sine beta rather. So we'll have this as a result. Then moving this way, we have our result as 2 minus 3 over 2 equals to, then we are left with root 5 over 2 sine beta. Can you see that? So if you observe carefully, this will reduce to having 1 over 2 equals to root 5 over 2 sine of beta. Then half, we cancel out half, we are left with 1 equals to root 5 sine beta. All right. From whence we have our sine of beta to be equals to 1 over root 5. Can you see that? Now, as it is now, it is necessary that we get the cosine of beta because of what we are seeing in this figure. All right. As you will see, you will discover that the cosine of beta is needed. All right. So let us quickly get the cosine of beta. The reason for the cosine of beta, to get the cosine of beta will be useful in finding line EF. Can you see line EF in the figure? Look at the figure carefully, locate line EF. The cosine of beta will be useful in getting that length, that line EF, all right? So because of that reason, we shall find the cosine of beta. Very, very important. So let's go over to finding it. Now to get the cosine of beta, recall from my trig identity that cosine of beta is equals to the square root of 1 minus sine squared of beta. All these are trigonometric results, all right? So this is equals to the square root of 1 minus, now the sine of beta is already given as this, all right? So we have 1 over root 5 all squared, and that will give us the square root of 1 minus 1 over 5. Can you see that? And this is equals to writing 4 over 5, which will give me 2 over root 5, all right? Hope you agree with that. So that is the cosine of beta. Now, we've known that already from the figure. From this figure you are seeing here, now looking at triangle EFC, let's consider triangle EFC. Triangle EFC, let's go there. From triangle EFC, the cosine of beta is equals to line EC divided by, let's look at it carefully, line EC divided by EF, all right? EF. Hope you can see that. Now already here, EC is already x over 2. Then we don't know EF, all right? We have to find EF. We don't know that. And this should be equals to 2 over root 5. That is the cosine. Can you see that? Then on multiplying, we can multiply out so we can get our value. When we multiply out, we have our result. This implies that we have x root 5 over 2 equals to 2 EF. From whence we have our EF to be equal to s root 5 over 4. Can you see that? Very interesting. I think there's no mistake anywhere. Let's look at it carefully, because I don't want us to make any mistake to avoid the monotonous acts. All right, because mistake bring about boredness. I don't want that in this particular situation. Now we've gotten the length of EF to be s root 5 over 4. So in that case, we are good to go. The work is completed by this data. Now, if you look at, now let's consider this triangle specially. Look at triangle AEF, all right? Let's look at that triangle AEF. Have you seen that? So the sides are not completely given in terms of x. In triangle AEF, one side AF is s root 5 over 2. The side EF has been found now to be s root 5 over 4. Hope you remember. Then already, yes, we've got to that side. So these two sides we've gotten are enough to get the value of x. All right. Now let's consider the area of triangle AEF. Area of triangle AEF. All right. So area of triangle AEF is equal to half of the base. Now we can consider this. We can consider EF as the base and AE as the height. So we have it as half. This is what did I say just now? EF, right? EF is the base multiplied by AE. All right. So which is equal to writing half. Now AE is already given us. What is AE? Let's look at AE. The expression for AE is here's it again. 2 we've gotten sorry, it's EF, not it's EF. What is EF we wrote? Yes, EF. Our EF is already s root 5. So we have it as s root 5 over 4. All right, then AE. What is AE from the figure? S root 5 over 2. So we'll have it as x root 5 over 2. So this is what we have as results. Very, very interesting. Now, don't forget we are given from the problem that the area of this particular triangle is 80 centimeters squared. Do you remember? Let's go to the statement of the problem again. Over here, you see it here. Can you see that? Look at it. Let me illustrate it. Look at it over here. Can you see this? Look at it. 80 centimeters squared. So in that case, I can come here and put, I will equate, let me take more page, but the page is exhausted already. I can now come here and say, therefore, 80 is equals to, now this will give me x squared, 5s squared, all right, over 16. Can you see that? When you multiply this, you will get 16. And when you multiply the numerator, you get 5x squared. From whence we have 16 times 80 equals to 5s squared. Undivided by 5, we have x squared equals to 16 times. Now, this will give me 16 again, which is 16 squared, all right? Verify that when you divide through by 5, you get this result. So is the case, all right? So on taking the square root, we have x to be equal to 16. So we've gotten the value of x to be 16. Now we cannot get y. We are given a condition from the statement of the problem. What is the condition? The condition is over here. They said find the value of x plus y squared, given that s plus y is equal to 4, all right? S plus y is equal to 4. So we can say now, if x plus y is equal to 4, we have that y, then y, let me remove this side to be neat, then our y is equal to 4 minus x, all right, which is 4 minus 16, and that will give us minus 12. So my y is minus 12. Therefore, the value of x plus y squared is equals to 16 plus minus 12 squared, all right? That will give us 16 plus 144. So on addition, what do we have as results? It's 10, 160. So the value of x plus y squared is 160, all right? So that is the result. So take note of this particular problem. We're done with solving it. So I advise you to take your time to go through it once, twice, and try to get a full grasp of everything I've explained to you. So if you are not clear, you can make a comment, and I promise to do my best next time to bring about clarity. As I said in passing, I render an online private math tutoring service. So if you're interested in my service, be very free to get across to me for a detailed explanation of concepts. Not only online math tutoring service, I also assist in your assignment. So in case you are given an assignment, you can get across to me and I'll help you in that also. So thank you very much for paying attention. I do really appreciate your presence and your patience. I'll provide another fascinating mathematical video when next we meet. So thank you very much and do have a good day.